Morning, folks. I'm Dave Canterbury with Self-Reliance Outfitters in the Pathfinder School. And here at the Pathfinder School in Southeast Ohio, we teach lots and lots of classes from basic, intermediate, and advanced survival to intensive navigation, ropes and rigging, wilderness first aid certification courses, edible medicinal plants, and lots of other classes you can find under the training tab at selfrelianceoutfitters.com. We look forward to seeing you in 2025. Now, today, what I thought I'd do today is I want to talk to you about the transit. And the pocket transit, particularly the Brunton pocket transit, is a very good tool to understand and be able to utilize if you need to. It's not a compass you would necessarily use for navigational purposes, although it can be used for that. It's more used for mapping purposes, creating maps, cartography, self-made maps, and things like that that you want to be very, very accurate. And we'll talk more about this transit as we go. Stay with me. So the transits we're going to talk about today are going to be the new D-Light transit on the left and the older Brunton transit on the right. They both have exact similar features. They're both in degrees, although you can buy these in mils, quadrant, or degrees. And quadrant comes in handy for certain things that we'll talk about in the future in this series of videos on how to use a transit. But the D-Light transit has a battery compartment on the bottom that you can see right there that allows it to be lit up with a button on this side so that you can light that transit at night, and that's why it's called the D-Light transit. The transit on the right is just an old school Brunton transit, and this is a co-branded transit. I get that thing to focus in well for you guys there. It's a very old one. I say very old, probably 40s, 50s, 60s time frame, somewhere in that neighborhood. But it's a very reliable tool. Still just as good today as it was the day it was manufactured. Okay, and you can get leather cases for these transits, or you can put them in the M2 case, which is a military case for the M2 transit. I have a very old one here that's brown, probably from World War II time frame that this transit came in. And this is a newer one that you can order off their website, although this one's older than that. But you can order these brand new off their website for this style transit if you choose, or any other transit that you have that's a Brunton style transit. So one of the first things we should speak to is how do you open the transit and how do you store the transit, okay? When you pull the transit out of the case, it looks like this. It's got a hinge side, and it's got a side that kind of looks like a hinge because there's a hinged piece there in the siding arm. However, this is the side that opens. So if you look at the solid hinge side that's screwed on both sides, you open the opposite side and you just put your fingers in there and pinch, just like that, and it will open, all right? Pretty simple. You can see it just closes down and snaps over the top. If you just put your thumbnail in between there, you can open it right up. Now, when you store the transit, it has a mirrored side and a clinometer scale side, basically, or a control arm for the clinometer. That's the side you want to the front. So it's on the snap side. So the mirror is not on the front side. If you were to fall on it or smack it or something like that, you're not going to damage the mirror. So you always store that thing with that clinometer arm to the outside. Okay, so once you have this thing open, you can open the siding arm and the peep sight depending on the compass that you have. It may fold to the inside. This one folds to the outside, okay? And it will depend on how old your transit is, how that front peep sight works. But the control arm will fold out from the compass itself. And then you have, obviously, a couple things we need to talk about. First, you have an adjustment screw here on the side, and that's for adjusting declination on your compass if you're trying to use this with a map. And then you have a pin here that actually freezes the needle in place when you close the lid or when you push the button down to help stabilize it while you're taking readings, okay? You also have a couple levels in here. You have a flat level and you have a horizontal level. Those will come in important later. Then you also have a variner in here that moves underneath everything where those levels are attached. That moves by this control arm we talked about on the back. And that is for measuring things on incline or slope, okay? We'll talk about that later, but that's what that portion is. Then you have a scale around the outside. This one's in degrees, as I said. They also can be bought in mils or quadrant. Mils are more for military use. Quadrant is something that's used for geological purposes, but also is very, very good when you're doing self-mapping or cartography work, and we'll talk about that in the future. But for our purposes and for what we're used to most of the time, this one is in degrees, and it will work fine for that, okay? Obviously, you have a needle in here, and you have a white side that is magnetic north, and a black side that points south, all right? Fairly simple as far as compasses go. You have a siding mirror here with a window in the siding mirror, a front peep sight, a rear siding arm that has a foldable sight on it as well. And that pretty much takes care of the pieces and parts of this compass, all right? And then you have a scale on the back of this compass, or a chart on the back of this compass that talks about sign for different angles, all right? Again, more geological stuff there, okay? But we'll talk about some of that stuff in the future because it's important when you're doing self-mapping as well. Now, one thing that you'll notice on this compass is, if you look at it, east and west are backwards on this compass, okay? Compared to north-south, south being down here, west being on the opposite side it should be. The reason for that is a Brunton compass or a Brunton transit like this is what's called a direct read compass. In other words, when I point this compass at something in this direction, and this is the proper direction to point this compass if you want to read the north needle, we'll talk about that in a few minutes, all right? But whatever degree reading that needle's pointing to, that is the degree reading the front of your compass is actually pointing to. You don't have to move a bezel ring to get needle in the doghouse or any of that stuff. This is point and shoot. You point this thing at an object, you line it up, the degree reading on the compass where the needle is pointing is the degree reading for your travel direction, okay? And you can see this one's set to 0 declination. There's a pin right there, and you can move that again with this screw on the back side to match your map. The biggest difference navigation-wise, and again, this is not the best compass for navigation on the fly, but it's more accurate than other compasses in that it can measure to the half degree if your eyes are good enough, but definitely to the 1 degree because it's broken down in 1 degree increments instead of 2 degree increments like most compasses are. All right, so let's discuss shooting a travel bearing or taking a travel bearing with this compass as if we were using it for navigational purposes in the woods, because it works for that just fine. Now, there's one thing you have to remember with this compass that's different or kind of counterintuitive to any other compass, and that is that to read the white needle, and again, it's direct read, you have to hold the compass in this configuration with the mirror backwards. Then the front of the compass is giving you a direct read of 200 degrees in this case, or 210. I haven't got my glasses on, but that is the direction the front of the compass is pointing, right? If you turn it the other way, which you can do, you have to understand that the black needle is going to give you the bearing of direction of travel to the front of the compass. And that really depends on how you're using this compass. You can use this just like a regular compass and hold it at waist level that doesn't have a mirror on it, point it in the direction that you want to travel, and then take a direct reading off the compass for your bearing, to write that down and begin your travel, okay? That's one way of doing things. Now, you notice there's a level inside this compass here. And what that's made for is to make sure that that compass is dead level so that you get the most accurate reading you can. Now, it's hard to do that when you're standing still with it and messing around. It's easier to do it if it's on a tripod, and it's got slots on the side of it here to go on a tripod mount, specially made by Brunton. We'll talk about that as well. For now, just get that thing as close as you can to level when you're trying to take a bearing. And then if you want to, you can stop the needle in place so that you can tilt the compass up to look at it. Just like that, okay? Point it out at the direction you want to travel, whatever that geological feature or tree or rock or whatever it is that you're traveling to, point it in that direction. Let the needle settle a little bit, kind of bounce it a little bit. That'll stop it. Bouncing around, boom. Check your azimuth and go, all right? That is going to be the most easy way. Now, if you are leapfrogging and you want to stay on azimuth, then you're going to have to go to the next object and move your body until that needle hits the degree reading that you started with, so that you stay on line. That's one way to take a reading off this compass. Frontwards, or this direction, reading the black needle. This direction, reading the white needle, or the north side of the needle, okay? Now let's talk about all these arms and sights and mirrors and all that stuff, okay? If we want to use this compass like a conventional compass, in other words, we want to use this mirror to view this, which we really don't need to do too much because we're not moving a bezel ring, all right? You can put this sight up and look through this sight through this window on the back of the mirror at an object, let the compass settle, and then, again, push that button, and that will stop it. And you can then have a travel bearing that way. So you're actually aiming this thing at something with your dominant eye, closing your non-dominant eye, looking through this sighting window, or looking at this directional arrow. Either one will work. But I find that these two little tits in between the circles there make it really easy to line that hairline up that goes through that open sight window with an object off in the distance, and then just lock it so that I know what my bearing is, okay? Very, very simple. Now, if you want to see what's going on, you could tilt this thing. It doesn't matter. You can still see through the sighting window, but it works better with it tilted almost straight up to look through the sighting window at another object. Now, you can also tilt this all the way down, and you've got a secondary sight in the front here that's got the same things. And then you've got this stick-up point on the top of this one. You have a stick-up point on the top of this one. So you can look through the two and line up on that outcropping at the top there, that little nipple sticking out, and line it up between these two up down and do exactly the same thing. Point it in the direction of desired travel, lock it, and see where you're at, okay? And take a direct reading from the black side because you've got the mirror to the front. So your azimuth is going to be on the black side, not the white side. Remember, anytime you've got the mirror to the front, your direct reading is going to come from the south side of the needle. If you've got the mirror to the back, then you can read the white needle. Now, the other thing that you can do is you can point this in the direction you want to point. This works really good if you're trying to do something downhill, all right? And you can look in this mirror and close your dominant eye, and you can line this line up with the center of that sighting arm, and then look at the front and make sure that you are pointing in the right direction that you want to travel, and just line that up till it's in the middle. And then again, stop it, take your bearing, and go, all right? That's another way to use this, especially if you're looking downhill at something. That works really well because you can just adjust the mirror to where you can see it, point the compass downhill, get it lined up, stop it, and take a direct reading, okay? That's a really easy way to do that as well. If you mount this compass on a tripod and you can control that level so that you have this compass in dead level position and stationary, now you can use this rear peep and this front peep and get a deadly accurate reading for azimuths, especially if you're trying to do map work of some kind or survey work. That's when this thing really shines. So if you're out there trying to make a map of an area, we've talked about self-mapping so many times on my videos, this compass is the one you want to use if you're going to self-map an area, because it's going to be way more accurate than anything else that you could do. You can buy the tripod mount. I'll tilt this forward so you can see it a little bit. Yeah, tilt it this way first, and I'll turn the tripod. You can buy this tripod mount. And you can see it's got an adjustment on it so it free swings down here at the bottom, and you can tighten that down like that, and then it pivots in this direction as well. And it pivots all the way to one side so that you can use the inclinometer. It has a very simple adjustment on the side to open it up, and that's what locks that compass in place in those two slots that we talked about. And you just pull it into those slots, and you lock it in place, and you're ready to go. You can buy this tripod mount separately from the tripod so that you could use it with any tripod you had, although you've got to be cognizant of the metal it's made out of. This Brunton tripod is non-magnetic aluminum. However, you could use carbon fiber or something like that just fine, and you could use any tripod you wanted with this mount, and you can buy this mount also from Brunton's website. Again, the advantage of this tripod is you can get this thing dead level, all right? You can also use this tripod for the inclinometer side of things. We'll talk about all those things a little bit more in detail as we go. I just wanted to get a quick video out that shows you the parts of the Transit, how to use the Transit, how to understand what it does and how it does it, that it's a direct read Transit and why the letters are backwards on the compass, east and west, and a couple different ways you could take bearings on the fly. All right, guys, listen, I appreciate you joining me out here today for a video, just a quick introduction to the Brunton Transit. We'll talk more about that in this video series on the Brunton Transit and the different ways that you can use it and things that you can do with it. I just wanted to give you a quick introduction, a couple ways that you can shoot bearings with it to get you started in case you have a Transit or have access to one already. I appreciate your views. I appreciate your support. I thank you for everything you do for school, for family, and for our business, for all of our sponsors, instructors, affiliates, and friends. And I'll be back with another video as soon as I can, guys. Thanks.